On this first problem, we're just going to practice finding a limit as n goes to infinity. We did this in an earlier chapter. I believe it was chapter 2. So if I would like to find this, I'm first going to have to substitute in the formula that I was given for s of n. And yes, you have to write out the word limit every single time. And of course, if I'm going to apply the limit, I probably don't need it to look so messy over here. So the first thing that I could do, of course, would be to distribute. And I'll get rid of all those messy parentheses. Still have limit in the front, haven't applied the limit yet. So now I'll have 8n cubed over 3n cubed and 12n squared over 3n cubed and 4n over 3n cubed. And then, based on the rules for limits, of course, I can split them. So we'll come down here in the second line, and so I'm going to split limits for everybody. And then I can start looking at either reducing or just beginning to take the limits, because remember, when we were looking at limits as n goes to infinity, this was when we were applying our rules using the degree of numerator versus degree of denominator. And so I could just start looking at that without even simplifying, although certainly I could simplify these fractions. So when I go back and I look at the first term, I go, oh, well, those degrees are the same, so the answer is going to be the leading coefficient over leading coefficient. And on the next one, oopsies, that's supposed to be a cubed down there. I don't know how this cubed over here got so darn big. We need to fix him. And so on that second one, the degree of numerator is smaller than the denominator, so that means it's going to 0. And on the last one, the degree of the numerator is smaller than the denominator, so that one's also going to 0. So I get a grand total of 8/3. And again, this is review from previous chapter. So I'd like to be able to use my summation rules that I learned for I squared, I cubed. So the first thing, of course, I want to do is to get rid of the parentheses because they're in the way. So let's make those get outs the way. And when I get ready to do the sum, I have to think about what variable is actually being substituted for. What's the counter on? And I can always tell by looking at the bottom of sigma, because that tells me the variable that I'm going to substitute in for consecutively until I get to n. So that's the variable I'd like to get by itself. And I'll ask the quick question of, isn't this still the same thing that I had written up there? And the answer, of course, is yes. So that means that this front piece is really nothing more than a big fat coefficient. It could be 4 over 1,000, or 7 over 20, any of that. It doesn't matter because it doesn't have an I in it. I just want to keep the I by itself. So I'm going to pull that coefficient to the front. Again, I still have the limit sitting out here. I'll just put the coefficient in front of sigma. And so now I have a formula for the summation of I, which I'm sure you just shouted it out right now. Good job. You guys are so smart. Must have a really good calculus teacher. Which is n times n plus 1 over 2. But I don't have the n value, so I must leave it generic, which that's okay. Now I'm going to start canceling some things out if I can find them, and I go, oh yeah, well, let's see, the 4 and the 2, that'll reduce. This n will go away, so now I just have 1 down there. So let's see what I have after all that messy crossing out. And while I'm at it on top, I might as well now distribute that 2. So I'm going to have 2n plus 2 over just the n on bottom, because remember that 2 got canceled out. And then I go, oh, it's a fraction, but both parts of the top are being divided by n, so I can split it. And when I do, I'll have 2 pieces. So the first piece will be the 2n over n, that'll be the front part, plus the second piece will be the 2 over n. And then again, using my rules with looking at degree of numerator over degree of denominator. Oh, whoops. Helps if you actually write down the right thing, Torres. Let me fix it. It should be an n. Okay. Yay. So now, of course, this is going to cancel out, and as n goes to infinity, I just get 2, because there isn't any place to even substitute in for an n. And then over here, the degree of the numerator is smaller than the denominator, so that's going to go to 0. So my grand total is 2. So what I would like for you to do is try letter B. Note that in order to simplify this all out, you're going to have to FOIL first and then distribute. So pause the video and see if you can actually get this one worked by yourself. So make sure you have this first piece. First I FOILed and then I distributed. And now I can split the 3 individual terms and pull everything out that's not an I in each term. So make sure you wrote limit for each term, you wrote sigma for each term, and you pulled the coefficients to the front of each sigma. So there's the coefficients. Notice I left the i's. Here on this term, if I pull the coefficient to the front, I just have a 1 left over. So now I'm ready to start filling in my formulas for I and I squared and the constant. So check each piece carefully. So now I've substituted in all the formulas. The formula for I, the formula for I squared, and the formula for the constant. And so then I'm going to get ready and start looking for things that I can cancel out. So here the n's will be gone. I'll get rid of 1n. That'll turn into a 4. I'll get rid of an n. Now I'll have an n squared. That'll turn into a 4 and a 3. Continue with the next step. So I simplified out, and now I'm ready to do some splitting and start taking the limit. And so now I can look at each piece separately. The limit for this, of course, is just 2. Here the n's will cancel, and I'll have 4. This one's going to be 0, because the numerator is smaller than the denominator. The next one is 8/3, because the degrees are equal on top and bottom. The next one is 0, because the numerator is smaller. And the last one is 0, because the numerator is smaller. And if I add that up, all these thirds will be 26/3. I hope you got it all by yourself.